You know, deep beneath the waves, there's a silent revolution going on. It's a story all about ambition, incredible precision, and engineering that is right on the very edge of what we think is possible. We're going to go 78 meters under the sea to see how China is building the world's first true high-speed undersea railway, the Jintang Tunnel. This is engineering on a whole other level.
So you hear this nickname, right? Infrastructure Maniac. And at first, it might sound kind of like a criticism. But what's really fascinating is that, for the most part, it's not meant that way at all. It's actually become a kind of tribute, a nod to the sheer scale and honestly, the mind-boggling speed of China's projects, which have left engineers all over the world just shaking their heads in amazement.
And just to wrap your head around that scale, look at this number. In a little over a decade, China has rolled out more than 45,000 kilometers of high-speed rail lines. I mean, that is more than every other country on Earth combined. They've built an entire planet-spanning network in the time it takes some countries to approve a single line.
They have built the highest railway on the planet, cruising across the oxygen-starved Tibetan Plateau. They've stretched the world's longest bridges over huge expanses of open ocean. So, after conquering the land and building over the water, there was really only one frontier left for their engineers to tackle.
Yep, after mastering the land and the sky, the next great challenge was to go under it all. And this wasn't just about digging a hole. It was about building a high-speed superhighway in one of the most hostile, unforgiving environments you can possibly imagine.
So this whole massive mission, it started with a really specific problem. You have the Zhoushan Islands, a huge hub for shipping and fishing, and they're sitting right there, so close to the mainland, but they were completely cut off from the country's high-speed rail grid. So the question was, how do you plug them in?
For decades, if you lived in Zhoushan, your life was basically run by the weather and the traffic. You had to rely on ferries or bridges that were slow, always jammed, and totally at the mercy of the sea. A big storm could roll in, and it often did, and just like that, the entire island chain was cut off. It was pretty much the last major piece of China's eastern coast that wasn't on the railway map.
Okay, so how do you solve a problem like Zhoushan? Well, the solution was, as you might expect, incredibly ambitious. They didn't just want another bridge. China's mission was to build the Ningbo-Zhoushan high-speed railway, and the absolute centerpiece of it all was this audacious tunnel dug directly under the Jintang Strait.
And this is the key thing to get. It's not just about the tunnel. That tunnel is the final, critical 16-kilometer piece of a much bigger puzzle, a 77-kilometer high-speed line that will finally and permanently connect the Zhoushan Islands to the rest of the country.
And this is where the engineering just gets wild. The tunnel dives down to 78 meters below sea level. I mean, at that depth, the water pressure is just immense. It's enough to pulverize ordinary construction equipment. We're talking about a totally hostile place to build anything. But here's the kicker. They aren't just building a tunnel. They're basically building an underwater racetrack. The entire thing is designed for bullet trains to fly through at 250 kilometers per hour. And that right there is a world first. No one has ever engineered an undersea tunnel of this scale for those kinds of speeds right from the get-go.
Honestly, this project was a catalog of engineering nightmares. You've got that crushing water pressure. You've got one of the world's busiest shipping lanes right over your head. But the biggest challenge was actually underground. The ground itself is constantly shifting between soft, gooey clay and rock-solid granite, a whopping 28 times in total. It's like trying to drill through a layer cake made of mud and then diamonds. So, to take on conditions like that, you can't just buy something off the shelf. No, you have to build monsters. So, let's meet the titans of the deep.
Say hello to Dinghai and Yongzhou. These are the two colossal tunnel boring machines, or TBMs, custom built for this job. They started at opposite ends of the route and right now are digging towards each other through total darkness with just one single, incredibly difficult goal: to meet perfectly in the middle. And just so you can get a sense of how big these things are, the cutting face on these machines is nearly 15 meters across. That's as tall as a 5-story building. This isn't just a drill, it's a moving factory that's literally eating its way through the earth.
And the weight? A machine like Dinghai is 4,350 tons. It's this self-contained steel beast, and it's smart. It was built to change its cutting tools on the fly, grinding through hard granite one minute, then carefully digging through soft clay the next, all while building the concrete tunnel behind it as it inches forward.
Now this is the part that just blows my mind, the precision. How in the world do you make sure two machines, each the size of a 5-story building, digging for miles under the sea, meet up perfectly? Well, they're guided by China's BeiDou satellite navigation system. It feeds them real-time data, constantly correcting their path. And the goal for this underwater meetup, an error margin of less than 2 centimeters? That is just unbelievable.
So, okay, we've seen the incredible how. The engineering is just fantastic, but the why might be even more important. Why does this one tunnel, under this one strait, actually matter on a global scale? This is where it gets really interesting. This chart really tells the whole story. Look at the famous Channel Tunnel between the UK and France. Trains have to slow down to about 160 kilometers per hour. Japan's legendary Seikan Tunnel, about 140. But the Jintang Tunnel, it's being purpose-built for 250. It's not an adapted tunnel, it's a true high-speed railway, and it just happens to be underwater.
The impact here is so much bigger than just a faster commute. Economically, it connects one of the world's busiest ports to the mainland, creating what they call a 1-hour rail circle that's going to supercharge the whole regional economy. But strategically, think of this as a dress rehearsal. If they can pull this off, it proves they have the tech and the know-how for even bigger, crazier undersea tunnels. It's proof of concept for some truly nation-building ambitions.
So when you really look at the Jintang project, you're not just looking at concrete and steel. You're seeing this amazing mix of incredible speed, satellite-guided precision, and just this powerful national will to overcome any obstacle that nature throws in the way.
And that leaves us with a final massive question. Now that this kind of technology is no longer theoretical, it's been proven to work, it really makes you wonder, what's next? Engineers are already studying an even crazier project, a 123-kilometer tunnel across the Bohai Strait. What used to be science fiction is now becoming a serious question of not if, but when.